We're now finally on the last tutorial of lesson 2.4, where we want to find all of the complex zeros of a function. And we're given one complex zero. And then we're going to write out the linear factorization of this function. So the first thing we can know is when we're given one complex zero, x equals 2 plus 5i, we can immediately know that the conjugate x equals 2 minus 5i is also a zero of that function. So then what we're going to do is we're going to use synthetic division just like we did with real numbers, only this time we're going to put this 0 up in the box of 2 plus 5i. And as you can imagine, the process is just going to be a tad bit more complex than it would be with a real number. So then we're just going to put all of our coefficients in, 1x to the fourth, negative 6x cubed, 35x squared, negative 50x to the first, and negative 58x to the 0th. And we're going to bring down the 1. 2 plus 5i times 1 is just 2 plus 5i. When I add this negative 6, I'm going to get negative 4 plus 5i. For the real part, I add the two real numbers, and then the complex doesn't change because negative 6 doesn't have an imaginary component. So when I multiply this 2 plus 5i by this negative 4 plus 5i, I'm going to have to FOIL them. And what happens when I do that is 2 times negative 4 is negative 8. 2 times 5i is 10i. 5i times negative 4 is minus 20i. And then the last becomes 25i squared. So then we have negative 8. Simplify it, we get negative 10i. And then any number with times I squared becomes the opposite sign. So we just have minus 25. I can also add the negative 8 and the negative 25 to get negative 33, and the minus 10i remains. So I've got negative 33 minus 10i. So then I have 2 minus 10i. And I'm going to have to do the same thing and keep FOILing. So 2 plus 5i times 2 minus 10i is going to give me 4 minus 20i plus 10i minus 50i squared. So same deal, I have 4 minus 10i plus 50. And then I'm going to get 54 minus 10i. So then if I put 54 minus 10i up here, 54 minus 50 is 4 minus 10i. And finally, I'm going to FOIL these, hopefully for the last time. 2 plus 5i and 4 minus 10i. I have 8. The outer is minus 20i. The inner is plus 20i. And then the last is minus 50i squared. So as you can see, the inner terms cancel out. We have 8 plus 50 essentially, which is positive 58, exactly what we want to see, because negative 58 and positive 58 gives me a remainder of 0, telling me that 2 plus 5i is indeed a 0. And now we have a depressed function down here with 1x cubed, this term times x squared, this term times x, and this term as my constant. So now what I'm going to do is take my other 0 that I had mentioned earlier, the x minus 2, or x equals 2 minus 5i, and we're going to take this depressed polynomial that we just came up with, and we're going to look at 2 minus 5i, and then we're going to have 1, negative 4 plus 5i, 2 minus 10i, and 4 minus 10i. And the 1 comes down. We get 2 minus 5i. Negative 4 and 2 gives me negative 2. And then the 5i and the negative 5i cancel out. So now I can just take 2 minus 5i times negative 2 and distribute the negative 2, which gives me negative 4 plus 10i. 2 and negative 4 is going to give me negative 2. Negative 10i and positive 10i cancel out, so we're just left with negative 2 again, which we know is negative 4 plus 10i. And notice that 4 and minus 4 cancel out. Negative 10i and positive 10i cancel out. We're left with 0, and that also confirms for us that 2 minus 5i was a 0. And finally, we are left with, we had x minus 2 plus 5i, the quantity. We have x minus 2 minus 5i. We have, and then we're left with, since our original one was x to the 5th, now we've got x cubed minus 2x squared minus 2x. I'm sorry, ignore that. Our original function was actually x to the 4th, so these are going to be x squared minus 2x minus 2. So now you can see we have a quadratic function. So we're not quite done yet because we can factor that. There's no easy way to factor it, unfortunately. We'll have to use the quadratic formula. So let's go ahead and do that. X equals the opposite of b, so 2 plus or minus the square root of b squared, which is 4, minus 4 times a times c, so 4 times 1 times negative 2, all over 2a, which I should have just kept 2 because a is negative 1 in this case. So x equals 2 plus or minus 4 minus what amounts to be negative 8. So 4 minus negative 8 is 4 plus 8, which is 12 over 2. 12 breaks down into factors of 4 and 3. 4 is 2 times 2. So we know that we can take a 2 out, and we're left with 3. So we have x equals 2 plus or minus 2 radical 3 over 2. Each term has a 2, so we can cancel them all out into 1s. And so essentially we have x equals 1 plus or minus radical 3. So if we simplify these complex factors up here, we get x minus 2 minus 5i. We have x minus 2 plus 5i. And then we simplified this into, or didn't really simplify it, we factored it into x minus 1 plus radical 3. And we also have x minus 1 minus radical 3. So I could simplify that if I wanted to, but for the sake of time, we'll just leave it like that. And if you were to look at a graph, obviously you wouldn't see the imaginary zeros, but you should find that you have a 0 occurring at 1 plus radical 3 and 1 at 1 minus radical 3, and it should look like a parabola shape. Now I just have this one for you to try to see if you can figure out all of the complex zeros of this function h of x.